This is RD Sharma solution. We are taking chapter number 17, that is increasing and decreasing functions, and the exercise is 17.1. Now this question, we have just seen that a is greater than 0, then the function was increasing. We showed that. The question here is we have to prove ax plus b. Same thing is given, but a is less than 0. So if you are going uphill, what do? We start from say x1, go to x2, x3 like that. x1 is lower than x2 and the domain is also given, which is real number. A real number is everything, negative, positive, decimal, everything which can be represented on a real number line. That is called the real number. Please remember fx is equal to ax plus b. That means if I change the value of x, you will get a value of y. So fx1 is ax1 plus b, fx2 is ax2 plus b. And also given a and b are constants. They will never change. And a is less than 0, that is, it is negative. If I show it on the number line, a less than 0 means you are talking about the left hand side, all the numbers which are negative. What will be the change? How it is going to be decreasing. So we are saying we are taking two numbers x1 and x2. They belong to the real number and this x1 is less than x2. So just remember we are taking for numbers say 2 or 3. 2 is less than 3 like that. Then next thing comes is this x1 and x2 are such that x1 is lower than x2 or x1 is less than x2. Now both sides we will multiply by a. But what will happen if I multiply by a? That is, if you have 2 less than 3, and what about the less than sign? If I multiply it with a number which is less than 0, which is negative. So if I multiply it by negative ones, for example, I'm just taking an example. So multiply it by negative 1, what will happen? This will be negative 2, this will be negative 3. What will happen? The sign will change. Now negative 2 will be greater than negative 3. So multiplication with a negative number always change the sign. If it is less than, it will be greater than. We are saying x1 is less than x2 whenever we multiply this with a negative number. For example, it is given in the question a is less than 0. So ax1 now will be greater than ax2. All clear? Just add b. B is a constant number. B lies in a real number. So if we have minus 2, just add 1. I'm just adding some value. B, just say 1. What will happen? This will be negative. Just put the value first. Negative 1, negative 2. Again, negative 1 will be greater than negative 2. No change. So adding b will not change anything. The sign will remain like that. But what is this, Shro? Initially I told you ax1 plus b is fx1. It is the value of the function at x1. What is ax2 plus b? It is fx2. So we started with x1 less than x2 and we found that indeed when x1 is lower than x2 or a value x1 which is lower than x2, the value of the function at x1 is actually greater than the value of function at x2. Alright. So that is why fx1 is greater than fx2 and this shows what? Decreasing thing. So you're not going up, you are actually coming down. You're going down. So that is why this implies fx is decreasing function on this real number. Now explanation I have given, but the writing work is what you have to perform. This is how you are going to do. Please remember to put a less than 0 properly because that is the core. dy by dx you don't have to use. People have been solving these with dy by dx. This exercise doesn't need dy by dx or differentiation. Show that fx is equal to 1 by x is a decreasing function on 0 to infinity. Now this fx is 1 by x. Now it is saying that it is decreasing function and 0 to infinity. What does this 0 to infinity means? See, just make a number line and see where 0 to infinity lies. We are not talking about 0 to infinity. Forget about that. Take it out from your mind. Just remember we are talking about a positive number. Okay? Positive number. You have to show that it is actually decreasing. Decreasing means you are not climbing up the hill. Actually, you are coming down the hill as far as this function is concerned. This function will have some graph. It will follow certain rule. It will follow certain path. And that path in this 0 to infinity, you will see a downhill scenario. So x1 is less than x2. The fx1 and fx2 hold a different relationship. That is why it is a decreasing. You'll just see it now. So this is always in this kind of question we say we are taking x1 and x2. that is belonging to this domain which is given in the question, 0 to infinite. So we are saying x1, x2 are the positive numbers. Negative 100, negative 1, this will not be done here. Okay, it's only positive. So we are saying x1 and x2 belongs to 0 to infinity. Actually, they are positive numbers. Then this x1 and x2, we are just saying that one number is lower than other number. X1 is less than x2. 2 is less than 3, for example, just to make you understand. But whenever I do 1 by 2, 1 by 3 or take the reciprocal, the sign will change. The relationship will change. 2 was lower than 3, but 1 by 2 is higher than 1 by 3 because 1 by 2 is 0.5 and 1 by 3 is around 0.33 something. So the angle sign or the relationship of less than and greater than will change. So when I take the reciprocal, or when you are going to take the reciprocal, it is going to be greater than. 1 by x1 will be greater than 1 by x2. Alright. So we are calling 1 by x1 is simply fx1 only. And when we put x2, it will be fx2. So the trend is whenever a number is lower than other number, the value of the function of the lower number is actually higher than the value of the function at the higher number. You got this? x1 is greater than is less than x2. fx1 is actually greater than fx2. So x1 is less than x2 implies that fx1 is actually greater than fx2. So this is a different thing. Means less than means increasing, but less than greater than means decreasing. So how you are going to go about it? How are you going to write it? This is how you are going to write in your exam or in your classwork. Please note it. Show that fx is equal to 1 by x square decreases in the interval 0 to infinite and increase in the interval negative infinite to 0. So there is one more question coming like this. So please understand it very carefully because I am going to give you all the explanation you hear. Just make a number line. It's quite confusing when you have 0 infinity, negative infinity, 0 like that. But the best thing is you make a number line. It will take just few seconds. And negative to infinity, infinite is a number which is infinite. You cannot even imagine what number is that. Nobody knows also that what number is that. Alright. So 0 to infinite is what number? Minus infinite to 0 is what number? Why are you not writing in it is infinite to 0? There is slight change or say complication that they put it in the question so that it is complex for the student. But the only thing is we are talking about 0 to infinity. 0 to infinity is nothing but positive numbers. All positive inclusive of 0. Second interval, negative infinity to 0. All numbers negative. So positive numbers and negative numbers, the domain I am showing, they are talking about two different domains or two different intervals. That is, you have to show in one interval, the function is actually decreasing and in the interval negative infinity to 0, it is actually increasing. So let us see what way we are going to go about it. There are two things, so we'll go for two cases here. The function will remain the same. Function is fx equals to 1 by x square. Please remember, we don't have to do it by derivative. People have been solving it by derivative. No. So we start with 0 to infinity. So I'm taking it as case 1 just to make a distinction between these two parts because this question is not one part, this is two part. You'll find one question with only one half part just now. So case 1 we are taking the first one, that is 0 to infinite. We are taking two numbers x1 and x2 which is belonging to this 0 to infinite. So essentially we are talking about the positive numbers. And I'm also saying we are also declaring that x1 is less than x2. Two numbers, one number is lower than other number. So don't worry about 0 to infinity. Forget about it. Just imagine that you are only dealing with positive numbers here. So how are we going to get 1 by 1 plus x square? Let us square it. x1 square and x2 square. Just square both the sides. When we square both the sides, just take any number, any two positive numbers. Say 2 less than 3. It is between 0 to infinite. Now just square it. What do you get? 4 less than 9. So if you square it also, the angle or you can say the less than sign will not change. It will remain like that. It won't affect at all. Now add 1. If you add 1, it doesn't matter, right? If you add 4 with 1 and 9 with 1, what will happen? This will be 5, this will be 10, so 5 will be less than 10. It will not affect. So the less than sign will remain. But the thing will change if you take the reciprocal of 5, 1 by 5 and 1 by 10. The angle or the relationship will change. 5 was less than 10. But 1 by 5 is greater than 1 by 10. That is 1 by 5 is 0.2 and 1 by 10 is 0.1, which is higher. 0.2 is higher. 0.2 is a higher number than 0.1. So that's what I'm saying, that 5 is less than 10, but 1 by 5 is greater than 1 by 10. So the relationship between these two will change. So we will take the reciprocal, and the reciprocal, soon we take the reciprocal. The next thing will be to change the sign or the relationship. Now the left is greater than right one. And what is this thing? This is fx1. What is this thing? This is fx2. fx1 is now greater than fx2. So if x1 is less than x2, the function value at x1 is higher than function value at x2. That is, the relationship has changed. This less than has given rise to the greater than. That means the function is decreasing. You are not actually going uphill, you are going downhill. Okay, you got the idea? Now we are turning ourselves toward the second part, increasing. Coming to the next part, which is the case 2 here. No need to make case if you don't want, but case 2 will make the distinction quite clear. Again, same thing. x1 and x2 is now in the domain which is negative infinity to 0. That is, I told you, don't worry about this domain etc. Just imagine that you are dealing with a negative number. You are taking the negative number, but thing is 0 is inclusive here. That is also the point you have to see. So we assume that x1 is less than x2. Just square these two numbers. Now what will happen? If you have a negative number, what will happen if you square it? The angle sign or the less than sign will change or not? It will change. Let me show you here. I'll take any number, any random number between negative infinity to 0 just to make you understand what I'm trying to say it here. So if I take any number which is negative here and two numbers which are low, one number is lower than x2, we always go increasing from left to right. Please remember. So if you take -2 and -3, actually -2 is greater than -3. -2 and -3 have a relationship. 3 is greater than 2, but -2 is actually greater than -3. That is, -3 is less than -2. Now square it. When you square it, what do you get? When you square it, you will get 9 and 4. Now the sign will change. -3 was less than -2. But indeed, when you squared it, 9 is greater than 4. That is why x1 square is greater than x2 square. Now you add 1. Doesn't matter. 1 added. The sign will not change. You have just seen in the case 1. Now take the reciprocal. I told you the reciprocal will also change the sign. That is, the greater than sign will become less than sign. That also I explained you in the previous case 1. What is this one? This is x1. What is this 2? fx2. And these are the function. So we started with x1 is less than x2. And then x1 is less than x2 implies that fx1 is less than fx2. So the point is that you are going uphill. You are going up. So you are getting an increasing function in negative infinity to 0. Alright. So this, how are you going to write it? So the next thing is, I have to show you how you are going to write it, because writing is very important, because examiner will only know that you know the question when you actually solve it properly, writing every stuff which I explained. Now show that 1 by x square is neither increasing nor decreasing on R. Now the previous question and this question has no change. They are equivalent. At negative to infinity, we said what it is decreasing. We said 0 to infinity, it is increasing. We already showed that in the previous question. So we have just done it. But so there is just a twist in this question. Means the question has twist, answer has no twist. Answer will remain same the way we have done. So we are talking about real number. Real number is all from negative infinity to infinity. So you can divide these two. So negative infinity to 0, it was increasing. 0 to infinity, it was decreasing. If you remember, we have just done that question. So increasing, decreasing, but you know that it is increasing, decreasing. That means in whole R, don't worry about the middle one. You just talk about whole of the range. Previously, in the previous question, we showed about the half range. So one time it was increasing, one point it was decreasing. But the real range or real number range is from negative infinity to infinity. All the numbers that is possible in the world are real numbers. You just have to add one more line and solve the question as it is in the previous question number 6, which we did. We will divide this whole question into two parts. That is, we'll divide the domain into negative infinity to 0 and 0 to infinite. So negative to infinity to 0, I told you that it was increasing. We showed it also. In 0 to infinity, we showed it as it is decreasing. So this is okay. In different domain it can increase and decreasing. But what about negative infinity to infinity? If you take the whole range R, one time it is increasing, one time it is decreasing, it is confusing. It cannot be. So that is why it is neither increasing nor decreasing. Now let me show you here. This is the solution. Same thing you have to do. As I told you, you have to divide this real number into 0 to infinite, negative infinity to 0. Same thing you have to do for 0 to infinite, show that it is decreasing. Again from negative infinity to 0 you have to show it decreasing. And since 0 to infinity, negative infinity to 0, that is the real number. So one time it is increasing, decreasing, it is not possible. So you can just say it is increasing or neither increasing nor decreasing. If it in one range it is increasing, it is okay. But in the same range, if it is increasing, decreasing, it is neither increasing nor decreasing. Without using the derivative, show that the function fx is equal to modulus x. Please remember, this exercise has strictly forbidden us from using the derivative. So we are talking about fx equals to modulus x, strictly increasing, strictly decreasing in different domain ranges they want. So first we will take A, and it is saying that the function is actually modulus function. The modulus function is a very simple explanation it has. If x is greater than or equal to 0, it is a positive number. Modulus x will give you x. If x is less than 0, that is x is a negative number, then modulus x will give you negative x. So this is the whole explanation of a modulus function. Just remember that. So let us come to this 0 to infinite. So we are taking two numbers x1 and x2, and we are saying that this belongs to 0 to infinite. I told you 0 to infinite, don't worry about that. What is it? It is just a positive number. They are just positive numbers. So you say x1 is less than x2. There are two numbers, x less than x2. And this is positive number. You have 2 less than 3. You take modulus, it will not affect their positive number already. So if you take the modulus also, it won't affect. Doesn't matter. It will be less than only. So this left part is actually fx1. The right part of the angle sign is fx2. So fx1 is lower than fx2. If x1 is less than x2, fx1 is lower than fx2. It doesn't change. So that means it is strictly increasing in 0 to infinite. This is quite clear. Alright. Now coming to the second part, which is saying strictly decreasing in negative infinity to 0. Now we are again taking x1 and x2 belonging to, now the domain has changed. It is negative infinite to 0. So x1, x2 belongs to negative infinite to 0. Actually, we are talking about negative numbers. So when we are talking about negative number, x1 is less than x2. Now just see here. We are taking the negative number. So just take two negative number and make a relationship. If you are confused, take real examples. So I'm showing you a real example. The number always increases from left to right in the number line. So negative 2 is actually greater than negative 3. So if I want to show it as less than sign, so negative 3 is less than negative 2. That you already know. But when you will take modulus, what will happen? This will be 3. This will be 2. Now 3 is greater than 2. So when you take the modulus, the less than sign will change to greater than sign. So modulus x1 has now become greater than modulus x2. Alright. This is fx1. What is this? This is fx2. So it has become greater. So x1 less than x2 implies fx1 greater than fx2. That means this function is strictly decreasing. Right? For less than, if for less than value means two values are, one value is less than the other one. If it gives you function is also less than, it is increasing, or otherwise it is decreasing. That can be used as a backup say knowledge you can have. Now how are you going to write about it? There are mathematical symbols that you have to use that I highlighted here, right? You have to show examiner. This is what you have to do, right? Without using the derivative, show that the function fx is equal to 7x minus 3 is strictly increasing function on R. What is R? R is a real number. Again I am saying real number means what? All positive. All number positive. So from negative infinity to infinite, you have to take negative number also and positive number also. This is fx is 7x minus 3. So you know how to go about it. Just take two numbers x1 and x2 in this real number, that is x1 x2 has to be in this real number, and every one number is a real number actually. It will fall in a real number. Real number is a very big set. So in this case x1 is less than x2. So if I take any two numbers, say 2 and say 5. I am saying 2 is less than 5, right? Now I am multiplying it with 7. What will happen? Just see it here. I am multiplying both sides by 7. So it is 14, it is 35. So 14 will be less than 35. So the less than sign will not change. 7x1 is less than 7x2. Now just subtract 3. If you subtract 3 from 14 and 3 from 35, it will be 11 and this will be 32. That will also not change the relationship between them. It will remain less than. So this is fx1. If you say x1, it will be fx1. If I put x2 here, it will be fx2. So essentially what you got, it is less than only. We started with x1 less than x2. We found that the function at x1 is actually less than function value at x2. So that means the function is strictly increasing function on the real number set. And this sign, if it change, that means it is decreasing. But in this case, it is increasing. So whole scenario, you have to follow this procedure to solve it. This is how you're going to write. Okay, just note it down. So this is all about this 17.1 increasing and decreasing functions. Thank you so much and study well.